So we can distribute, we can factor, we can FOIL, so we can Leoff. Well, no, it's not literally Leoff. You know, we're not doing last inside outside, but rather we're going to take a trinomial and try to put it into what we'll call factored form. So I'll take my easy example that I did from before. Now I want to put this in factored form. I want to put it in a form where there's going to be two binomials that will look like we're going to FOIL them. Again, we're just reverse distributing here. Now the question we need to ask is, what do we need to multiply into this? So factors of this, 6 in this case, that add up. I think they're called addends, but I'm not going to make you memorize that. Add up to, I think that's easier. This is how I learned it, at least. Two numbers that multiply to this, that add up to this. Run through the factor pairs of this, because there's infinitely many numbers, and infinitely many pairs of numbers that add up to 5. Like 1 and 4, 2 and 3, 100 and -95. So there's infinitely many possibilities for this, but there's a much shorter list for the number of numbers that are factor pairs of 6. So we got 1 and 6 are possibilities. You might want to write down all of the factor pairs, or at least try to go through them in your head. So 1 and 6. Does 1 plus 6 equals 5? No, it doesn't. 2 and 3. 2 plus 3 is 5. There's our pair of numbers that we're looking for. We're going to put that 2 and that 3 over here. And then the x squared will obviously become the x and the x of the first part of that FOIL process. And then these are all adds, so we're going to put a bunch of pluses. Now you can FOIL this out as a good check. So x times x is x squared. 3x plus 2x is 5x. And then 2 times 3 is 6. We did it. Let's do another one. Not 7x, because the x will be obviously taken care of by the two first x's. The outs and the ins will be 3x plus 2x. Those will be your linear terms that you're adding together. So don't worry about the x, we're worried about the coefficient. Like I said, we're trying to find two numbers that multiply to 10, but here it's -7. A negative times a negative is a positive, but a negative plus a negative is still a negative. So we're looking for two negative numbers. Okay, what are the factor pairs of 10? 1 and 10, but I just said they need to be negative numbers, so -1 and -10. Does that work? -1 plus -10 is -11. Okay, that doesn't work. So then we can try -2 and -5. 2 and 5, 2 times 5 is 10, but -2 times -5 is positive 10. The -2 plus -5 is -7. We did it. Go straight into it. It's going to be x minus 2, x minus 5. Again, you can FOIL it out to check. X times x is x squared. -5x plus -2x is -7x. -2 times -5 is 10. We're done. Okay, so we need a factor pair that multiplies to -3, but adds to -2. So to multiply to get to a negative number, you need a positive and a negative. So one of each. 3 itself is a prime number, so we only have 2 factor pairs to work with. -1 and 3, and then 1 and -3. Which one makes sense for this problem? 1 and -3, that works, because -3 and 1 added together is -2. So those are the numbers that you'll use for this problem. 1. It doesn't matter in which order you write these factors. So I could have written them like this. And it's the same because multiplication is commutative. We can rearrange this blob and this blobette to switch spots, and it's going to be the same product. So don't worry about that. But what if I gave you a very similar problem? Well, now we still have the same factor pairs of this -3. So what are we adding to get to +2? Well, it's going to be this one up here. X -1, x plus 3. Now it's a +3 because we need to get to +2. 3 minus 1 is 2. Duh. So the difference between these two problems was that the linear term was either positive or negative. If your constant term is negative, your factor pair is going to be one positive, one negative. Which one is it? Which one is positive, which one's negative? Well, the bigger factor is going to be determined by the linear term. If the linear term is positive, then the bigger factor of your constant term needs to be bigger. So when you subtract 3 and 1, you get to a +2. And then if your linear term is negative, then that bigger factor needs to be the negative. So we got 1 minus 3 is -2.